All right, welcome. My name is Ryan Hoger with Temperature Equipment Corporation. I have Dick Grant with me today from Cultiva Systems. Cultiva is an indoor agricultural HVAC system that we represent. And with everything going on in Illinois in terms of the grow facilities being built, we definitely wanted to get Dick online with you guys to kind of explain how the technology works and why it has advantages over traditional HVAC systems for these types of applications. So with that, I'm going to let Dick drive.
Okay, thanks, Ryan. Cultiva Systems is a manufacturer. We provide, we refer to it as DIAS, or Dedicated Indoor Ag System Equipment. We sell nationwide and in other countries. We've got projects in Canada. We work through local rep firms, and then we work with engineers and contractors on the projects, because all of us seem to be learning as we go through this. Our point of sale, though, is always through the local rep. And we generally want to be involved from the design through the sale and startup. And we provide ongoing support to the end customer. We'll get a little more into that as I get into the slides here. I'm going to go through some basics here because some people are familiar with this, some are not. But basically, within a grow facility, there are 4 rooms that you will generally always see. You've got what you call the mother room, which is where they keep the mother plants. This is their genetics that they protect. And from those mother plants, they take cuttings and root those in the clone room or nursery. Once those plants have rooted and got to several inches in height, they'll move them to a veg room. In the veg room, they'll grow them to possibly 12 to 14 inches in height. And at that point, then they move them into the flower or bloom rooms. Normally, you'll see in a facility, there will be 1, maybe 2 mother rooms, 1 clone room, and there's generally 1 or 2 veg rooms. And those rooms can then feed or supply anywhere from 8 to 10 to 14 flower or bloom rooms. In the mother room plants, they're large, but the clone and veg, their plants are real small, so you can get a lot more density in there. And when you move them into the flower or bloom room, they grow to quite large in size. Okay, generally your mother room, like I said, that's where they maintain their genetics. And they take cuttings from these mother plants so that they can be, what they're trying to do is replicate the genetics of that plant and continuously get the same thing. General conditions that you're looking at, if you're looking at the high pressure sodium lights or metal halide lights, generally we're seeing those rooms designed at like 75 degrees and 50% relative humidity. If they're doing it with LED lights, generally they'll run the temperature a little warmer, up around 80, but then they'll maintain somewhere in the range of 50% relative humidity. In the clone room, this is where they put the small plants and get them rooted. This is your stage 2. Typical conditions you're looking at there, again, if they're running the high pressure sodium, which are much higher temperature, they'll run the room at about 75 degrees, and they will maintain a little higher humidity in these in the clone room. So they're generally around 55%. If you're looking at LED lighting, they'll run it a little warmer, but again, around 55%. One of the things, the dehumidification load in the clone room is small. These plants are not giving off. In fact, in a lot of cases, they have to add humidifiers in these spaces. And one of the things that you will find that on the HVAC or dedicated indoor ag systems, you're going to need auxiliary heat of some form because there's not enough heat and not enough energy coming off of the plants to allow us to reheat with hot gas. The plants are real vulnerable at this point also to small pests, so it's pretty critical that they maintain this temperature and humidity ranges. Next, you move into the veg rooms. The veg rooms, generally they're a little warmer, and you're looking at a little higher relative humidity again. The high pressure sodium, they'll run them a little cooler, like 80 degrees. If you're running LEDs, you might see them running as high as 83 degrees. The dehumidification load in there, again, is small because these plants are small and they're not giving off a lot of moisture. One of the things that's interesting about the veg rooms is that the plants are very susceptible to fluctuations in temperature and relative humidity. One of the first projects we did, they were using typical commercial HVAC equipment in there, and they were seeing substantial swings in temperature and humidity. And what the grower told us was that once they took them out of the veg room, it put them into the flower rooms, it took a couple of weeks for those plants to readjust because they had been stressed so heavily in the veg room. So temperature and humidity control in the veg rooms are extremely critical, but it's critical in all of these rooms. The final room, growing room, is called the flower or bloom or grow rooms. You know, your typical conditions that you're looking at, 70 to 83 degrees, and then 45 to 55% relative humidity. And a note here on this is that when you're working with your grower, it's critical that you get them to tell you the conditions that they're going to be looking for. One of the jobs that we had, they'd given us 75 and 50% relative humidity. After the job was built and installed, they came back and said, well, we really want to run it at 70 and 50% relative humidity. The equipment was undersized and we couldn't get to that condition. So you've got to be sure and make sure that the grower gives you all of that information. Because we're doing such a heavy dehumidification load, we're doing a lot of reheat. And you've either got to reheat via recovered energy, which is hot gas reheat, or you've got to supply auxiliary heat of gas or hot water coils, etc. One of the things that they do in the grow rooms is they introduce CO2. Your normal ambient CO2 in the atmosphere is 300 to 500 parts per million. The plants need 1,200 to 1,500 parts per million, so the growers are introducing CO2 to the space. In some cases, they'll do this by actually open flame in the space. Most of them, though, are actually going to stored canisters outside. You'll see a tall CO2 bottle on the outside, and then the CO2 is interjected into the building. We can actually interject that CO2 through our air handlers, but in most cases, the CO2 people are introducing that through their own system. So that gives you an idea of what the overall room structure is within there. And then there's a lot of supporting spaces that are also involved. And Cultiva Systems is not generally involved in those supporting spaces because that's your typical HVAC equipment. The type of systems that we've seen applied in grow facilities, in the grow rooms, those 4 grow rooms that I was talking about, we're seeing people use chilled water. We're seeing cogen also. Cogen, because the energy demand is so high in these facilities, a lot of people are installing cogen facilities to supplement the energy that they can get from their providers. In most cases, we're also seeing dehumidifiers being used. Really what you see is a combination of standard HVAC equipment like rooftop equipment, split systems, et cetera. And then you've got small dehumidifiers. The Cultiva Systems approach is DX with full heat recovery, and I'll get a little more into that as we go. But the controls are the absolute key to these systems. As I mentioned earlier, the flat temperature and humidity control is critical, particularly in the veg and in the flower stage. Okay, the equipment that we provide, we actually refer to this equipment as dedicated indoor ag system, or DIAS. We're differentiating that from a DOAS, or a dedicated outdoor air system. It's designed specifically for the ag industry. In fact, we're doing our first job, which is I wanted to say partially, it's not partially, it's an alfalfa, not alfalfa either. I can't even remember what it is. But we're doing our first non-cannabis. Cannabis is the big driver, though, in this market. The precise environmental control is critical. As I said earlier, one of the first jobs we did, they did standard HVAC equipment. It was residential split systems. And the temperature and humidity swings were stressing those plants in the veg area. And when they moved them into the grow area, it took them about 2 weeks to recover before they could begin the real growth process. Our equipment, we can do DX air cooled, water cooled, and we can also provide it in the heat pump mode, although we see very little requirement for the heat pumps. We're providing full dehumidification with this unit. So we're not supplying typical HVAC equipment and then applying dehumidifiers with it. We do the entire dehumidification load in our unit. And then we use recovered energy, recovered heat to reheat that air to maintain temperature. So we're really minimizing the energy required to what's required to remove the moisture. Once we've removed the moisture, we have enough recovered energy to then maintain our temperature. Okay. The first piece of equipment I'll show you is what we call vertical. It's a vertical self-contained unit. It can be water cooled or air cooled. It's available in 10 to 45 tons. We've got variable speed Zilebeg fans, although generally speaking, once the fan speed is set, these things generally run at a constant speed, but it can be controlled. We're using 6-row evaporator coils so that we can get the full dehumidification that's needed. Then in addition to that, we've got what we call full condensing hot gas reheat coils. Most commercial HVAC equipment has partial hot gas reheat coils. In our case, we've got 2 independent circuits. Those independent circuits have variable speed compressors, and they've got 2-row full condensing hot gas reheat coils. As I said, we've got fully redundant refrigerant circuits to give us our maximum reliability. And then we factory install our Cultiva systems controls, and with all of its wireless capability and its BACnet, Modbus, any of the systems needed to communicate with the front end. See if I can get that. This is the vertical indoor unit. It's made to sit in the hallway. You slide that filter box up against the wall of the room. You return the air through the filters, and you can discharge out the top or out the front of the unit here. In a lot of cases, space within the hallway is critical. So we've maintained this unit at 44 inches in depth. And in general, what we're seeing a lot of people do is they will remove the filter box. The filter box that you saw shown on there was a side access filter box. What we'll do is build a filter sleeve in the wall itself and use front loading filters on the unit. So we minimize the depth that the unit extends into the hallway. The next piece of equipment that we have is a packaged rooftop. The packaged rooftops are available 10 to 60 tons, just like the The other units, the vertical units, we've got variable speed direct drive Zelabeg supply fans. We've got the 6-row evaporator coil. We've got two-row full condensing hot gas reheat coils. And then again, we've got the fully independent refrigerant circuits and factory installed Cultiva systems control. Here's a picture of the unit. One of the things you will note about it is that it's shown with a outside air intake, essentially a economizer cycle. That is there. This unit was actually built by Addison. We had to take the Addison unit and essentially which was a DOAS unit, and we gutted that unit to make room inside of that for our 6-row cooling coil. We've also got a 6-row space in there for a PCO air cleaner, which I'll get to in a minute. And then we've got our 2 hot gas reheat coils. All of these units can be water cooled or air cooled, and we will operate to -20. These units have to operate 365 days a year, 24 hours a day. So we've got to be able to operate in the dehumidification load all the way down to a -20 degrees F. As I said, controls, and maybe I haven't spoken enough about it, but the controls are absolutely the key to making these systems work. Barry Light, who is the originator and owner of Cultiva Systems Controls, has been working in the cannabis industry for about 7 years. He's been in the controls business, controlling HVAC unitary equipment for about 25 years, and has developed a tremendous amount of knowledge. Prior to that, he was actually a service tech. So the Cultiva Systems Controls, we've built all the programming for the equipment, and it's all factory installed. We can modify, and in fact, in a lot of cases, we do modify to meet the growers' requirements. The Cultiva Systems controllers have a full graphical user interface. One of the things that we see happening is, well, you can actually come up to it with a smartphone or a tablet and interface with that controller in the room. Some of the growers are having us install a tablet or a panel on the outside of each room so that they can walk up to it and see exactly what the conditions are that are inside of that room. There's no special software needed. It's done via the web. Communications protocols, BACnet over IP, BACnet MSTP, Modbus TCP, and Modbus RTU. So we can communicate with any of the control systems. This is a screenshot of an active trend log. One of the things to notice here is the blue line here is your humidity. That is set at 55%. And if you look at that, that's maintaining that within plus or minus 1%. Very, very tight. The green line is your temperature control. And again, the idea is to flatline those because the plants really do not like, or they don't adapt well to swings in temperature and humidity. All of these set points are field adjustable by the grower, but like I said, you want to make sure that you get the proper design parameters from that grower, because if they come in later and decide, oh, we want to lower the temperature and we want to lower the relative humidity, it makes it very difficult because those plants are still putting off a tremendous amount of moisture. And when you lower that temperature and humidity that you're trying to maintain in the room, the ability of the equipment to remove moisture is substantially reduced. I mentioned PCO Air Cleaner. I'm not sure how many people are familiar with PCO. PCO stands for photocatalytic oxidation. This module is 6 inches in depth, and between the 6-row cooling coil and the two-row hot gas reheat coils, there is a 6-inch slide-in filter tray in which these PCO air cleaners can be installed. This is not a Cultiva Systems product, but it's available and can be factory installed. If you look at the penny and the white media there, that white media is titanium dioxide. Titanium dioxide, when it's activated by UV light energy, UVC specifically light energy, it causes a reaction which creates what are called hydroxyl radicals. Hydroxyl radicals are similar to, I refer to them as a vapor form of hydrogen peroxide. It's a highly reactive radical. And anything passing through there, any VOCs or biologicals passing through that media where these radicals are created, the VOCs and the biologicals are destroyed, and going downstream, you've got CO2 and H2O. The hydroxyl radicals have a life of 10 to the minus 9th seconds. So they're created and die very quickly. So they'd never leave the surface of that media. You can see the UVC lights. You see the white through here. Those are your UVC lights. And this panel is drilled through the center, and we run the lights through the center of that. It's called center point PCO. There's a lot of different forms of PCO out there, but this is called center point PCO. One of the things that's unique about it is that your light energy from the UVC light degrades exponentially as you get away from the light. By putting the light through the center, we're never more than 3 inches from that light source energy. So we've got the energy required to create those hydroxyl radicals.
Hey, Dick, we have a question, if that's all right.
Yeah, sure.
All right, the question comes from Robert. When growers get a license to grow, are they regulated on how much they can produce? In other words, are most growers all the same size and production facilities, or do they vary greatly?
They vary greatly. Yeah, you go from the small, what they call craft growers, to the very high production grow facilities. I'll put it to you this way: we see jobs with equipment that can be anywhere from, let's say, $150,000, $200,000, $300,000, all the way up to, I've seen some jobs on one grow facility as much as $2.8 to $3 million worth of equipment. So the size can grow substantially. I actually had one facility that was in Canada that was a craft grower, and we actually don't have equipment small enough to really work well in that situation. The craft growers are going to have difficulty getting the kind of conditions that they need.
We had one other question. I think it was more for me. Victor asks how they can view the recording of the session. The recording will be at the exact same URL link that you guys registered on for this, and I can always send it to you again if needed. It'll take about 3 hours for me to compile the file and get it up on there. But then if you need to share it with a coworker or a buddy that's 10 states away or whatever, you can do that.
Okay. Room loads. You know, you can't go to the ASHRAE guide and find out how to calculate these loads. I'm sure it'll be coming before long. Cultiva Systems can help with that. We've got a good bit of experience working with growers and engineers that we've worked with over the past 4 to 6 years. Your equipment is going to be sized primarily on latent loads. The latent loads really dominate, particularly in the flower or bloom rooms. In the veg and the clone rooms, the latent load is not quite as dominant, but in those rooms, you've got to make sure that you've got enough auxiliary heat available, because you are going to have to remove the moisture, and if you can't reheat that air back up, you're going to overchill the plants. The equipment sizing for flower rooms, and this will give you an idea, is you're generally looking at 30 to 40 square feet per ton. So it is a very, very heavy load. The veg rooms, as we said, they're a little less, the load is a little lower. You're looking at 50 to 60 square feet per ton. Your typical flower rooms, though, this is your sensible heat ratio. This is where you run into issues with trying to do it with standard HVAC equipment. You're looking at SHRs in 0.5 to 0.60 range. The veg rooms, and this is where in some of our initial jobs, because of cost, people will try to use just standard HVAC equipment, and they're trying to get something in the range of a 0.70 SHR. The issue there is being able to control that equipment to the flatline temperature and humidity conditions that the plants are really requiring. Cultiva systems equipment, moisture removal. If you look at this, we're about 0.6 of a gallon per hour per ton. On a 30-ton unit, we're removing about 432 gallons per day. So a lot of moisture being pulled out of those rooms. A lot of that moisture, by the way, that water can be recirculated. They'll capture the condensate and run it back into the rooms. That gives you, pretty much an overview of what the growth cycle is. One of the next things that we're working on is the post-processing. Post-processing, your plants have been harvested. They're generally hung in a dry room. Most of you've probably seen tobacco barns where they hang the tobacco to let it dry and age, and it's done generally just in the open atmosphere. With cannabis, they're doing it in a controlled environment because they want to maintain the terpenes and the qualities of the CBDs, etc. If you dry it too fast, it becomes brittle and becomes worthless. If you don't dry it fast enough, you will end up with mold on the plant, and again, you end up having to scrap the crop. So if you over dry it quickly, you can ruin the crop. If you under dry it, mold and mildew, and again, you ruin the crop. We're working with some growers right now. Really what we've got to do is you've got to size the equipment to be able to remove a lot of moisture relatively quickly, because they want to get a lot of that moisture off the plants in the first 3 to 5 days to prevent mold and mildew. But they don't want to pull off too much of it. So what you really got to do is stage the temperature and humidity control down over those first 4 to 5 days. And the target, generally speaking, that we're seeing is the growers will tell us, well, I want it at 60 and like 40% relative humidity. If you look at 60 and 40% relative humidity in a space, it's very hard to take any moisture out of that space because you're limited by your suction temperature. The only way to essentially do something like that would be with active desiccant dehumidification. So what we're working on is gradually staging the temperature and humidity set points down. I think that long term, what we might see is we'll actually see measurements of moisture level in the plants and control to drag those moisture levels down from there. This is a picture of a project. This happens to be in Sacramento, California. That is 10 60-ton, 55-ton rooftop units. On 5, there's 2 units per room. There's 5 grow rooms there. So you can see that the equipment density is quite heavy. One of the projects in Sacramento has got 30 rooftops on, and they're actually on the roof of that building. So with that, we'll finish up. Thanks for joining. And if I can answer any questions.
We got another one here from Anthony. It says, when bringing outdoor air into the rooms, will they be controlled with economizer controls? And if so, will the dampers be in danger if the sensors fail, open or closed?
Well, great question, Anthony, because this is a process, and they do not introduce outside air to these rooms. These units are all 100% recirc. If you have a code official that requires that you introduce it, the grower will fight that very hard, because they're introducing CO2 into that space, and they do not want to throw that CO2 away. So we do not, we can supply a unit with an economizer cycle, but we haven't been required to do it yet. So generally, you will not have outside air on these rooms. They'll supply outside air to the hallways, generally through a DOAS unit, and that's the outside air to the building.
All right, let's see. Next question. Let me expand this a little wider so I can read it. From Michael, a question regarding outside air. If using outside air, what is used to prevent pollen contamination for the grow plants? I think you just answered that by saying it's 100% recirc. So you tried typing it while you were already answering it.
Okay. No, that's, we run in, and I should have said that earlier, but yeah, outside air is definitely something that, particularly if you're in an area where they're growing hemp, because in these grow facilities, they're growing female plants. They do not want anything to go to seed. But if you've got hemp growing close, the hemp could actually pollinate these plants if you bring in outside air
in. Ron actually asked a question about costs, and I'm going to assume that these are basically applied systems, and each thing is designed for the job. So the costs, I'm assuming there's no like rule of thumb for costs, which people want. But
well, I can give you a broad range. If you're talking about large tonnage, and I'm talking about 45, 50 ton equipment, you're generally in the range of somewhere between $2,500 and $3,300 a ton.
And that's the cost to a contractor, and then there's still the labor.
I would consider that the contractor's price, and then he's got the installation that's got to go with it.
For the end users on this call, it has to be installed and started up and electrically powered, right, and all that stuff.
Exactly. If you're going to smaller equipment, the dollars per ton get real high real quick. You can be as high as $5,500 to $6,000 a ton on a 10-ton unit. So that's where the craft growers are going to see issues, because the cost of that smaller tonnage equipment is very high. One of the things, though, that you've got to remember is that by going with the dedicated indoor ag system, a DIAS unit, as opposed to using unitary equipment and dehumidifiers, two things. One, you're using substantially less energy, but also your installed cost is substantially lower. You're not supplying, well, I'll give you an example. I was in a job in Florida. They had 22 5-ton residential split systems on that project. So it's 110 tons in that room. Also in that room, there were 17 dehumidifiers hanging in the space. The installed cost of that system has got to be high. And with the dedicated indoor ag system, one, you go into a room like that and you would probably have 2 or 3 units. You would have no dehumidifiers. All of your electrical distribution is going to be substantially less. You don't have all the piping for the condensate removal from the dehumidifiers, and you eliminate the fight that goes on between the HVAC equipment, and I'm referring to that as HVAC as opposed to dedicated indoor ag, but the fight that goes on between the HVAC equipment and the dehumidifiers. The dehumidifiers are actually adding heat back to the space. So
We have a couple more questions, Dick.
okay.
Anthony asks, do you see people setting up redundant systems, so basically double your specs for install?
Not generally. I mean, we'll see some safety in there, but we're not generally going to fully redundant systems. And I'll tell you why. For one, most of the grow rooms that we see have two units on it. That's what we like to see, at least 2 units. So we've got 4 circuits there, 4 independent circuits. Your maximum load required on that equipment is generally only required in the last 2 weeks of the grow cycle. During the first 6 to 7 weeks of the grow cycle, those plants are maturing, but they're not throwing off that full dehumidification load that you see in the last 2 weeks. So we'll see people oversize the equipment, but generally not more than 20, maybe 25%.
I think that also answers Don's question, which was, it was mentioned that 2 units were installed per grow room. Is this 100% backup or 50-50?
It generally, if you've got a grow room, you're not, if you've got a 70-ton grow room, you might see a max of 90 tons installed on it. But you've got to be careful because if you oversize that equipment too much, because that equipment has got to operate down to a very low load condition. If you think about those plants when they go into the flower room, they're maybe 8 to 12, 14 inches tall, and they're not giving off a tremendous amount of moisture. So that equipment has got to operate down at a very low load condition. And I need to go back and probably state something that I didn't earlier. We've got 2 variable speed compressors on these units, and we've got variable hot gas reheat, so that the first project we did, we had a lead variable speed compressor and a lag on-off compressor. We found that there were times in that 8-week grow cycle where the lag compressor coming on was not enough to handle the load, but that lead compressor unloaded all the way down was more than the load. So we were cycling temperature and humidity in the space. We went back and retrofitted that project to variable speed on both. So on our 20 tons and above, we're using Bitzer VFD compressors. Below 20 tons, we're using Copeland digital compressors. But we've got a variable capacity compressor on both circuits.
All right, a couple more questions. Dino asks, how do you recommend cleaning ductwork and equipment in between grow cycles to ensure there will be no contamination on the next round?
Well, we actually don't get involved in that, but I can tell you what they do. Most of the sites that we see are using duct socks, and so they will pull those duct socks down and wash them and then reinstall them. They may actually have a separate set that they install in between. They also go in and, again, I've only been told most of this, but they go in and wipe down that entire room and disinfect it, including the light fixtures. So it's a pretty substantial cleaning and disinfecting process that they go through.
Okay, Anthony asks, what's the plan when growers do perpetual harvest? I don't really know what that means.
Well, I guess there's a couple of things you talk about with perpetual. If somebody is growing in a room and they're harvesting part of that room continuously, um, I haven't seen that. What we see with most of them is that they'll have, say, let's say 10 grow rooms, and they're harvesting one of those grow rooms every 2 weeks, and then they're going in and spending a week to 10 days cleaning that grow room, and then they bring new plants into it. So by having 8 to 10 to 14 grow rooms, they have almost a continuous harvest, but it's not out of one grow room.
That makes sense. The one grow room thing might be more like for those craft guys you were talking about that are really small, doing their own thing.
Yes. Yes.
All right. Next question is from Kevin. Does this information apply to food growth products and facilities? And if so, are there any major differences to be aware of?
Well, the various food products, cannabis is one that gives off a tremendous amount of moisture. Some of the other vegetables, things that we grow, do not give off as much moisture as cannabis. And so each one of them is going to be a little different. But yes, we've designed this equipment specifically for the ag industry. It just so happens that right now the cannabis industry is where the money's at.
All right, Dick.
But we are looking at other, there are other people coming to us and saying, hey, can you help us?
I think that was our last question, Dick. I thank you for your time. For everybody that's on the call, if you need more details, reach out to your territory manager or reach out to me and I'll get you the information you need. If you're out of state and listening in, that's totally cool too. Check out the Cultiva website and you can find your local guy that way. And thank you for joining us, Dick.
All right. Thank you so much, guys.